Okay, this is the second video in the photoelectric effect series. This is going to use a simulator to explain how light intensity and the current produced from the photoelectric cell are related. So you'll see at the moment we've got violet light with a wavelength of 400 nanometers here, and the intensity is set to 0, in other words quite dim, there's no light shining on the photoelectric cell at the moment. And I'll have a look as I increase the intensity. You can see here at 43% there are now electrons being emitted from the cathode here, travelling across to the anode. If I increase the intensity even further to 100%, we can see there are a greater number of electrons being emitted in a given period of time. So the reasoning for this is that if we're at low intensity, we go down at 28%, you can see there are some electrons being emitted, but not as many, because when the light is of a lower intensity, when it's dimmer, there are not so many photons being produced. When the light is brighter light is a greater number of photons being produced, and that greater number of photons then landing on the cathode means a larger number of electrons therefore being emitted from the cathode. We can also have a look at the current down here. The electrons that are emitted and then go on to travel around the circuit, the electron flow is related to the current. Current in amps is measuring the number of coulombs of charge, in other words electrons passing a given point in 1 second. So here at 100% intensity we've got 0.141 amps, reducing it down 0.056 amps of current for 40% intensity. Over on the right here we can graph that, so current versus light intensity. If I change that slider, here you go, we can see that, yep, as light intensity increases, so too does the current.